This video is to allow you to correct the homework for section 2.2.5. They do give you information in the math notes, which is also in your toolkit, about the idea of showing multiplication with fractions on a rectangle. So for example, this one is 2/3 of 2/5. You start with the 2/5, and you're going to draw that by dividing your rectangle into fifths and shading two parts of those. Then they want 2/3 of that. So what you're going to do is now divide your rectangle the other way into thirds and shade in 2/3 of those 2/5. And that's, of course, this section right here. So then your answer is going to be 4/15. And remember that you should simplify, or another word for that is reduce the product if it's possible. So here we're doing the same type of thing. She noticed that 3/4 of the cars are sedans, half of them are white. What fractions of the dealership's cars are white sedans? So 3/4 of the cars are sedans, and half of them are white. So we want half of 3/4. So what you're going to do is you're going to start by making 3/4 on a rectangle. And so you're going to divide it into 4. So you can do that vertically or horizontally, doesn't matter. And you're going to shade in 3/4. And then you want to take half of that. And when you take half of that, since I divided this horizontally, I'm going to divide that the opposite way, which is vertically. And when I do that, I'm looking to shade in half of those 3/4, which should be this area of overlap right here. Now they do want you to label it. So remember, this was my 3/4, and this was my half of that. So your final answer is looking something like this. You can see I did mine slightly differently than theirs because they shaded their 3/4 at the top, but you get the same information, same answer. So half of the 3/4 is 3 out of the 8. Then they want it as a decimal and a percent. So to get the decimal, remember, you're going to remember that a fraction bar is division. So you're going to take 3 divided by 8. You could do that with long division, or I would let you use a calculator. And you end up getting 375 thousandths. And if we want to change that to a percent, we're going to move the decimal 2 places to the right and add a percent sign. For 291, they remind us that back in 289 from classwork, half of 1/4 and 1/4 and 1/2 look different, but the answers were the same. So now they want you to look at 2/3 of 2/5 and 2/5 of 2/3. So again, they should end up looking different, but giving you the same value. So if I'm going to do 2/3 of 2/5, I'm going to start by breaking this into fifths. And I'm going to shade in 2/5. My picture is not perfect, and yours doesn't need to be either. But I'm going to shade in 2/5. And then I'm going to come through and do thirds, specifically 2/3 of that. So 2/3 of that would be the area of overlap right here, which gives us 4 out of 15. This would be then 2/3 of 2/5. If I'm going to do it the other way around, now I'm going to start with the 2/3. And again, you can do that vertically or horizontally, it doesn't matter. So I'm going to shade in my 2/3. And then I'm going to do 2/5 of that, which means I got to come through the other way and do fifths and shade in 2/5. So that would be this here. In both cases, even though they look different, we get the same answer, which is 4/15. Both of them have rectangles that are divided in 15 pieces, and 4 are the overlap shading. Here you got to simplify it, which means you got to find the answer. So remember that when you see absolute value, it's representing distance. So 10 plus 2 would be 12. Absolute value of 12 is 12. Then we have a negative 32 and a positive 12. Remember that when you're adding values that have opposite signs, one way to do it is to subtract them and carry the sign of the number that has more whole. In other words, I'm going to just subtract them as though they're whole numbers. 32 minus 12, I get 20. But is that answer going to be negative or positive? Well, 32 has more of a pull in a negative direction than 12 does in a positive direction. So it's going to be negative 20. So figure out the answer, then think about the sign. Same thing here. I have 17 and 1/3, negative 50 and 1/3. They are opposite signs. So I'm going to subtract them as though they're regular values. 50 and 1/3, 17 and 1/3. And, whoops, I need to make that look like a 7, sorry. When I subtract them, the 1/3 minus the 1/3 will disappear. 50 minus 17 is 33. But, again, is this going to be positive or negative 33? Well, 50 and 1/3 is pulling more in a negative direction than 17 and 1/3 is pulling in a positive direction. So negative 33. Now, when I combine this with negative 5 and 1/2, because remember, subtracting 5 and 1/2 is the same as adding negative 5 and 1/2, I basically have the same sign. I have 33, which is negative, and I have 5 and 1/2, which is negative. So when I combine those, I get 38 and 1/2, which is negative. Because again, these both have the same sign, so we just combine them and carry the sign. Here, again, you're going to want to combine maybe first your negatives. Remember that again, subtracting is the same as adding a negative. So you combine these. I should see the work for that. So for this one then, you're going to have two of these that are negative, and you're going to want to combine them since they have the same sign. And then those will both combine and have the sign carried over. So in other words, if you take 5 and 37/100 and you add 1 and 89/100, you're combining them because they have the same sign. And of course you'd get 16, carry the 1. It's like 12, carry the 1. So 7 and 26/100. But that's going to be negative because, again, that's the sign on both of these. When you combine it with the 8 and 14/100, that's positive, so they're opposite signs. So now you're going to take the 8 and 14/100. That's a terrible looking 8, sorry. And subtract 7 and 26/100. Again, you're subtracting not because this is negative, you're subtracting because there's opposite signs. And then when you do that, you get 88/100. But the question is that positive or negative? Well, 8 and 14/100 is pulling more in a positive direction than 7 and 26/100 is in a negative direction, so it's positive. So here, for this problem, would you get the same final answer if you add first as if you multiply first? Of course, that's not the case. 2 times 3 would be 6. If you add 9 to that, you get 15, as opposed to 9 plus 2 is 11, times 3 is 33. So if you add first, you get 33. If you multiply first, you get 15. For this one, it's on multiplication. In that case, you would get the same answer. 2 times 4 is 8, times 7 is 56, or 4 times 7 is 28, times the 2 is 56. So when they're all multiplication, the order doesn't matter. And then which one could not represent a probability? Make sure you're writing the sentence explaining why not. And the answer is you cannot have negative probability. Probability has to be between 0 and 1. So 1 would mean 100%. 1% would be very low probability. 1/10 would be somewhere in between. But again, you can't have negative probability.